Okay, let's go ahead and get homework number 3 done. Again, I'm not only going to video this, but I'm going to make sure that I take pictures of it. So your choice, however you prefer. But please, I really think it's a good idea to go ahead and go back and check all of the answers. Okay, I think it's going to be great for you, helpful. So let me make sure you have your name on it. Okay, homework 3 was already due. Homework 4 was already due. So let's go ahead and let's look over it. First thing is, again, vectors. If vectors are in opposite direction, as in like there's just two and they're in opposite direction, we're going to subtract them. If there's two and they're in the same direction, we're going to add them. But if we've got two vectors and they are in the X and Y component, horizontal and vertical, now we're going to have to think about SOHCAHTOA. Okay, so these two were both in the Y component vertically, Y component vertically, and then we have the Y component and the X component, okay? So let's go ahead and let's take a glance and let's look at the homework here, get this done, double check your answers. The first one here, I've got opposite directions, so what I'm going to do here is I'm going to subtract, right? Again, we do not care about the negative value. We want the difference. That's all we want is the difference. So in this case, let's go ahead and do the bigger value in first. 1,200 take away 800 equals a net of 400 newtons, but the overall direction is going to be up. Why? Because this is the larger value, up. Let's look at the next one. Again, we have two vectors. They're both on the Y or vertically. We're going to subtract them, okay? We do not care about negative value, so we put the larger number in first. 800 take away 600 equals an answer of 200 newtons. Again, though, we're going to look and the bigger value is down, so my direction is going to be down. Next one over here, I've got the X and the Y component, but since I've got two on the Y, let's look at this first before we look on the X component. I've got opposite, so I'm going to subtract. 50 take away 50 equals 0 newtons. Okay, so when it comes to vertically, my net is going to be 0 up and down, meaning that it's not going to move up, it's not going to move down. But horizontally, though, I only have 1, so there is no addition, subtraction, no nothing. It's just going to be 20 newtons to the left. Okay, let's look at the next one. The next one here tells me that there are four free body diagrams that have vectors with them. Some of the vectors, though, are missing. The value, the magnitude of that vector is missing. Okay, so what we need to do is we need to look at the overall net force, meaning what is the overall answer going to happen? What's going to happen here to these free body diagrams? Okay, so let's look at the first one. Overall, it's going to cancel out and be in equilibrium or balance forces, which means 0 newtons. That means everything cancels out. How do I cancel things out? By subtracting them when they're in opposite directions. So if it's 200 down, it has to be 200 newtons up. If it's 50 to the right, it has to be 50 to the left. So A is 50 newtons, B is 200 newtons. Let's look at C. Overall, I'm going to get 900 newtons as an answer, but it's going to be up, meaning that this is going to be the larger value and this is going to be the smaller value when I subtract them. Okay, so in this case then, if I do the opposite, 900 and 200, 900 plus 200 equals 1100. My answer is 1100 newtons up. Go ahead and check yourself. Get 1100 newtons and take away 200 and you should have 900 as an answer. Let's look at letter D and E. So on D and E, overall, my net force is going to be to the left, 60 newtons. Okay, so overall to the left, 60. Nothing about up and down. So that means that up and down, since there are two forces, they must be in equilibrium and they cancel each other out. So 300 up should be 300 down. That way they cancel each other out and there's no right or left. There's only, there's no up and down. There's only right and left over. This one, my bigger answer is going to be to the left. So this is going to be the large number. This is going to be the small number. Okay, 60. If I do the opposite, and let's look at 80 take away 60 equals 20. Let's put 20 here. 80 take away 20 equals 60. So my answer is going to be 60 newtons. I'm sorry, 20 newtons, because my answer ends up being 60 overall for the net force. So 20. Next one, letter E down here, which we already did. We cancel those two. That way we can put into equilibrium. So 300. Let's keep going. I've got three vectors over here. Again, they're going to be, what do you call it? They have no magnitude, so we have to find the magnitude on the last one. But the overall answer is 30 newtons to the right. Doesn't talk about up and down. So whatever up and down is, they must make sure that they cancel each other out, correct? Those two. This one is going to move to the right, so this needs to be the larger number, and 20 is going to be the small number. Okay? So let's look at letter G first. 20 here, and something's going to be larger than 20 because this number, take away 20 equals 30, right? Or 50, because 30 plus 20 equals 50. This is going to be 50, because 50 take away 20 equals 30 newtons to the right. But what about here? What did y'all put for F and for H? What did you put? Hopefully you gave a value or you gave a number, but what should the number be? Is there a definite answer? And that's where I think some of us kind of like get off track with some of the questions here in physics, because you know, we feel like it needs to be a definite A or a definite B or a definite C. This is what it's going to be. You know what though? Not always like that. Why not you? Why don't you make it up? What did you put? Did you put 200 up and 200 down? Because if you did that, they cancel each other out, and you're right. Did you do 50 newtons up and 50 newtons down? They cancel each other out, and they equal 0, so then you're correct also. Did you do 1 newton up and 1 newton down? That works also. So whatever number you put here needs to be the same number over here, as long as they're the same number. So that way they can cancel each other out. I don't care what number value it is. You can put 0 newtons for all I care. But it needs to be a number, and whatever you put on the top needs to be the same one at the bottom. Okay? Let's keep going. Number 3. Draw a free body diagram with arrows only. Okay? No magnitudes. That means no numerical value for the following objects. A ball falling in the presence of air resistance. So a ball is falling. So F sub G or F sub W in the presence of air resistance. F sub F. Okay? No numbers, no magnitudes, just the arrows, but I can label what type of arrows those are. So we should do that. Let's keep going. A helicopter lifting off of a launch pad. Okay, so your choice. If you want to draw the helicopter, that's fine. Or draw a box. Put your dot in the center of it. It's moving up off of a launch pad, means that it's going up, right? F sub A from the engine, causing it to go up, right? And opposite of that is F sub F for frictional force, because this engine is forcing it to go up. Opposite is frictional force. Now, if some of you wrote weight force, yes, gravity is pulling down on it. I understand that. But the fact that there's an actual engine that's forcing it to go a certain direction, in this case it's moving up, then opposite of that is friction. Okay? If an apple is falling down towards the ground, okay, that would be gravity pulling it down. If I got a baseball and I tossed it down as hard as I can, the moment it released from my hand, the only force applied onto it is gravity at that time. So it would still be gravity pulling down. Okay, so I know some of us probably wanted to put an FG here, And F sub F would be the correct answer. Okay? The F sub F. I know that's a weird one, tricky one. And free body diagrams seem like they could be tricky because it looks like it could be one thing or another. Okay? Remember, on a free body diagram, you're trying to do kind of like a blueprint and represent what action is going on with all of the forces on an object with the fewest amount of letters, words, anything, okay? With as little as possible, you're trying to describe the situation, okay? So in this situation, whether I knew it was a helicopter or not moving up, I know that there's something that has an engine or some type of battery-operated, engine-operated object that is forced to go up, and the opposite of that was the friction of the air pushing against it, okay? Yes, I know that gravity is there. I know that, right? Unless you're like in the middle of outer space, every planet's going to have some type of gravity, okay? An athlete is running along a horizontal track to the left. Okay? Draw the person. We're going to draw that box or the person, whichever one you wanted to do. But no matter what, we're going to draw it straight up and down, horizontally. Okay? We do our dot in the center of that object, whichever one you did, whether the box or the person. And they are running along a horizontal track to the left. So that means that the longest arrow is going to be to the left, F sub A. That applied force came right from your feet. Okay? What is the opposite of F sub A? Like 90%, 95% of the time? F sub F for frictional force. Does it say that this person is jumping up and down? No. Does it say that this person is sinking into the ground because they're so heavy? No. So I know that this person is on Earth. How do you know? Because it doesn't say that they are located anywhere else. So they must be on Earth. So F sub G or F sub W pulling down. But because it doesn't talk about it moving up and down, then the up arrow must be equal in size, F sub N. And they did tell me that they're running along a horizontal track. So that's some type of surface, a normal force, okay? Let's turn the page. And I will take a picture in a moment. Let's go ahead and let's answer these questions over here. Please make sure that your calculator is in degrees. Okay? There are 4 forces that are acting on a hot air balloon shown over here to the right. Find the net force for the horizontal and vertical directions. So horizontally, what's my answer here? Okay, 570 newtons. Oops. Okay, and what direction is it moving? It's moving overall to the left. Vertically, I'm going to do my subtraction. I get 1070. Overall, what direction? Who's a larger number, up or bottom? Up. So it looks like overall, my object or my hot air balloon is going to move up and to the left. It's going to look something like, move something like this. When I find this, because this is what I want to find, okay, I'm going to go ahead and do my y-axis and my x-axis. Okay, remember what I told you. You start on the x-axis, either you go up or you go down. In this case, I have to go up so I can find my theta. And also, I'm looking for the magnitude of that arrow. I can see that this, look at that, produces a right triangle. And if I go to the opposite of this right angle, this is my hypotenuse. The theta and right angle produces my adjacent, and what's left over is my opposite. Okay? Let's go ahead and let's continue this. They want you to find the magnitude and direction, or the net force. These two words mean this and this. Okay? Let's go ahead and let's do this. I like to get the SOHCAHTOA out of the way. So I'm going to SOHCAHTOA. Your choice. You don't have to. You can do Pythagorean or you can do something else, whatever. But I want a SOHCAHTOA. And actually, you kind of have to SOHCAHTOA first. Right? Let's look. Do you? No, you can Pythagorean. Look at this. Horizontally, this direction, this horizontal leg is 570. Look at this vertical. This vertical leg right here is going to be 1070. Okay. With my highlighter, if I can find it, I can see that I have this leg and I have this leg. I have the A and the O. So I can come over here with the A and the O, use the tan to find my theta. So the tan of the theta equals the opposite over the adjacent leg. Or the tan of the theta equals 1070 over 570. Okay? 1070 over 570. 1070 divided by 570 comes out to the tan of the theta is 1.88. I just rounded, okay? That's not my answer. I have to do the inverse. I actually have to find the theta. Look, I'm looking for the theta. The opposite of the tan, opposite of this, is the inverse of tan. So that's when we're going to hit the second key, tan, and we find out, because we want to cancel that tan out. Okay? The theta equals 61.99 degrees. This is only part of my answer. Which part? It's the direction part. So we did this part now. Now let's go ahead and go to the magnitude. The magnitude is this hypotenuse leg. Okay? So you've got two choices. You can SOHCAHTOA or you can Pythagorean at this time. Your choice. I'm going to Pythagorean. A squared plus B squared equals C squared. Or 570 squared plus 1070 squared equals C squared. Right? So 570 squared 3249900 plus 1070 squared equals 1144,900 equals C squared, right? So let's add those two numbers together. Plus 324,900, 900 equals 146,9800 equals C squared. Not my answer at all. I have to do the opposite because I have a square here. So the opposite of square is a square rooted. So second key square, 146,9800 equals 1212.35. Wait a minute. If this is newtons and that's newtons, then this vector, this hypotenuse leg, is a newton. Now I've got the magnitude and direction done, both parts, and both parts are my answer. Okay, let's keep going. Next one here. It says here that a 24 kilogram crate is pulled to the right with a force of 82 newtons and to the left with a force of 115 newtons. Upwards with a force of 565 newtons. Determine the weight force acting on this crate using Newton's second law. All right, so F equals MA. The M is 24 mass in kilograms. The A is an acceleration of gravity, 9.81. So I think we did this one in class. 9.81 times 24 equals 235.44 newtons. And what is the weight force direction? That's a downward pull. Okay. So I'm going to go ahead and part B says, let's draw this free body diagram. I've got 235.44 newtons down. I have to the right 82 newtons, to the left 115, and upwards 565 newtons. Okay? So overall, now what do? Well, I break it down to the horizontal and the vertical components. So horizontally, which is my X direction, I'm going to 115, take away 82, right? Equals 33 newtons. Vertically, I'm going to end up with the bigger number first, 565, take away 235.44. So 565 take away 235.44 equals 329.56. Now let's go ahead and find the net external force, and that means magnitude and direction. And the word direction actually means the angle or the theta. So overall, if I look at it horizontally, okay, who wins, right or left? Left. If I look at the vertical, up and down, who wins? Up. So my object's going to go up and to the left, all right? So it's going to look something like this. What do I do next? I'm going to go ahead and come in with my y and my x axis. Remember, you start from your x-axis. You either go up or down. Since we're on this quadrant over here, we're going to go start at the x and move up, and that's my theta. That's my unknown. Okay? I'm looking for magnitude, which is the number value that goes with your vector, so that's my unknown. I can see that this forms a right triangle, and I'm going to go ahead and put in my right angle over here and move to the opposite, which is my hypotenuse. The theta and right triangle or right angle produces my adjacent leg, and left over is my opposite leg. Okay, now I know from this information over here, my horizontal is 33, so this is 33. I know that my vertical, they gave it to me, or I found that. So this vertical right here is 329.56. So with my highlighter, I have vertical and I have horizontal information. Okay, I like to highlight what I have. So step one for us is always going to be SOHCAHTOA. Who do I have? I have my A and my O, which is my tan. So the tan of the theta equals the opposite over the adjacent. I have the opposite and adjacent leg. I don't have the theta, so that's what we're going to solve for. So the tan of the theta equals 329.56 over 33. All right, just like that. So 329.56 divided by 33 equals the tan of the theta equals 9.99. Is that my answer? No, I want to get rid of this tan. So to do that, I need to do the inverse of tan. Remember that second key tan. So let's do second key tan, 9.99, close parentheses, comes out to a theta of 84.28 degrees. That is only part of my answer. For my second part, I just like to go ahead and SOHCAHTOA since I'm looking for the c-square. So I'm going to say 33 square plus 329.56 square equals c-square, right? So 33 squared equals 1089. 329.56 squared comes out to 108609.79 equals c-square. Let's add those two numbers up. Equals 109698.79 equals c-square. Now my answer, I need to get rid of that square. So to do that, I got to square root it. So second key square of 109698.79 comes out to, the hypotenuse leg is 331.21 newtons. The other two vectors are newtons, so this vector is also a newton. Okay, let's come back over here, finish up our answers. How are weight and mass different? let's do this over here. Mass is the amount of matter in an object. Okay? Weight is due to the gravity pulling on the object, right? What changes if you go to the moon? The weight, because the gravity changes. What stays the same? The mass, because that never changes. What force causes weight? Gravity. Next one, number 7. Says here, find the force of the larger skater after the two skaters push off from each other using the information in the diagram on the box to the right. Let's see. Well, I see that there's a problem. So no one mentioned this to me in class, did they? No, they did not. The problem here is that they didn't give you all the information. Let me go ahead and pull up my other paper. Looks like you do not have the acceleration number. You're going to need that number, right? Because F equals ma. And it looks like you're missing that A part of it. You have the velocity, but you don't have acceleration. So let's see. All right, so let's go ahead and let's say during, here's what it says on my other worksheet from last year. During a time period of 2.5 seconds. There's no way unless you have that information that you can answer it. No one mentioned it to me, so I'm not sure. So hopefully you're watching the video so you can see that there was a mistake here on the actual worksheet itself. So now I have enough information that I can do this. If I'm finding the force, F equals ma, and I'm finding it of the larger skater. Who's the larger skater? The 48 kilogram person. So it's in kilograms, so I'm going to leave that mass number alone of 48. Acceleration, though. I don't have it. I need to find. So to find acceleration, it's final velocity minus initial velocity over t. Now I have the time period, which was 2.5 seconds. So my final velocity was 2.5. My initial velocity was 0 because they started from rest. The amount of time that occurred, 2.5. So when I subtract 0, that's nothing. 2.5 divided by 2.5 equals 1 meter per second square. So my acceleration is 1. The amount of force is 48 newtons. Okay, that's how I got the answer. They didn't give you enough information, so I had to plug it in. Sorry, I need to change that for next school year. It looks like we're done with the answers here. I'm going to go ahead and take pictures and post that. And let me go ahead and do the video for homework number 4 as well. And then I will start the video over the lab. That way you can look over it before you take your quiz. Alrighty, have a great day. Bye-bye.